Assalamualaikum and hi everyone. This is the second video for topic 1, limits, and subtopic 1.1. This video is about the third learning outcome. Therefore, at the end of the lesson, students should be able to see find limit of fx as x approaches a over limit of gx as x approaches a when limit of fx as x approaches a equal to 0 and limit of gx as x approaches a equal to 0. For your information, to find the limit of a function algebraically, you have some techniques or methods to use. The first one is the method that you already know, that is find the limit by substituting the value that x is approaching into the function fx. If your function is continuous at that x value, you will get a value and you are done. You have found your limit value. That is what we have learned in the first video and also in this example. So now we will learn a new method with different situation, which is when you substitute the x value into the rational function, then you get 0 over 0. So, what you need to do? You must move on to another method to simplify the fraction so that you can substitute the approach value of x. This method is finding limits using factorization or multiplication of conjugates. If the solution for limit of fx as x approaches a over limit of gx as x approaches a is 0 over 0, that means we cannot calculate the limit of the given rational function by substitution. So, what we need to do? We need to simplify the fraction by using factorization or multiplication of conjugates. So to know and understand more detail about this method, we look at the example 4, 6, and 7. Example 4. Find the following limits. We are given 3 limits with rational function. Let's try the example 4a. Okay. Limits of x squared minus 16 over x plus 4 as x approaches negative 4. Okay. Firstly, we try to substitute negative 4 into the function. And we can see we get 0 over 0, which tells you to move on to the other method. Please remember, this question is not wrong. And what you need to understand, this limit that n in an indeterminate number, like this example, is said to be an indeterminate form. So, what is an indeterminate form? Okay. I give you 2 situations. The first one is, let's say you have 0 over 2, 0 over 100, and 0 over a. Then we know 0 over 2, 0 over 100, and 0 over a give 0. Okay. Now I give you the second situation. Let's say you have 2 over 2, 100 over 100, and a over a. So we know we can get 2 over 2 is 1. 100 over 100 is 1. And a over a also 1. But What is 0 over 0? Is it 1? No, because 0 over 2 is 0. So, 0 over 0? Is it 0? No. That's why we call 0 over 0 as indeterminate form. Then, how do we find the value of limit in indeterminate form? For this example, the quadratic expression in the numerator seems to be factorized. Notice that the numerator has x plus 4, which is same factor with the denominator. Then, we can cancel x plus 4 on the top and bottom of the fraction. Then leave limit of x minus 4 as x approaches negative 4. So now, we can substitute negative 4 into x minus 4 and finally get the value of limit is negative 8. For question B, it is same with question A. First, we try to substitute approach value 1 into the fractional function and get 0 over 0. We already know that it is an indeterminate form. Since the denominator has a quadratic expression, so we can factorize it and get limit of x minus 1 over x minus 1 times x plus 2. We can see here, the numerator has x minus 1. The denominator also has x minus 1. So, we can cancel x minus 1 on the top and bottom and get limit of 1 over x plus 2 as x approaches 1. Okay. Next, we substitute 1 into x and have 1 over 1 plus 2 and the limit value is 1 over 3. Same with question C, we have limit of x squared minus 5x plus 6 over x squared minus 4 as x approaches 2. In this example, we have quadratic expression for both numerator and denominator. So better we factorize the quadratic expression and get limit of x minus 2 times x minus 3 over x minus 2 times x plus 2 as x approaches to 2. So here we can see we can cancel x minus 2 on the top and the bottom and obtain limit of x minus 3 over x plus 2 as x approaches 2. And then we can substitute 2 into the fraction. And lastly, the limit value is negative 1 over 4. The next method that is used to find limit algebraically is multiplication of conjugates. It requires us to rationalize the denominator or the numerator. Functions that require this method must have a set either in the numerator or denominator or both. Now, we will try example number 6 by using this method. Okay, for example, number 6a, it asks to find the limit value of set x minus 2 over x minus 4 as x approaches 4. Firstly, we substitute 4 into the fraction and obtain 0 over 0. We already know this is an indeterminate form, which is it cannot solve by using substitution method. For this example also, we cannot use the factorization method because the fraction has no polynomial to factorize. So, what we need to do? Since the numerator has set, So we need to rationalize the numerator by multiplying both the numerator and the denominator with the conjugate of the numerator. Because we have zx minus 2, then its conjugate is zx plus 2, which the conjugate is the opposite sign of zx minus 2. So, we multiply the given limit with zx plus 2 for both numerator and denominator as shown. Next, we expand the numerator, which the process of multiply of these two third expression is very similar to multiply of two binomial, which is, the process is zx times zx, so we get zx squared, zx times positive 2, so we get positive 2 zx, negative 2 times zx, so we get negative 2 zx, and negative 2 times positive 2, so we get negative 2 squared. For the numerator, just leave it like this, no need to expand, because it has two different types of expression, which is one has no z and another one has z. From this also, we notice that we can cancel 2zx minus 2zx. And we get limit of x minus 4 over x minus 4 times zx plus 2 as x approaches 4. Since both numerator and denominator has x minus 4, then we can cancel it and leave limit of 1 over zx plus 2 as x approaches 4. Then we substitute 4 into zx and get the limit value is 1 over 4. Example 6b, we are given limit 9x minus 1 over 3zx minus 1 as x approaches 1 over 9. First, we try to substitute 1 over 9 manually into the fraction. That means you can calculate this limit value without writing. Okay. Then yes, we get 0 over 0. So we know when we get 0 over 0, so we need to use multiplication of conjugate. Why? Because this example has z in the denominator. Okay, so therefore we multiply both the numerator and the denominator with conjugate of the denominator. Okay, so the conjugate is 3zx plus 1. And we get like that. Okay. So for numerator, we just put in the bracket as shown. Okay, no need to expand because it's different pattern. Okay, which is one has z and another one has no z. Okay, we just expand the denominator. Okay, so we get 3zx times 3zx. So it is 3zx squared. Then 3zx times positive 1. So we get positive 3zx. Negative 1 times 3zx. So it is negative 3zx. And last, negative 1 times positive 1. So it is negative 1. Okay. Here we can see, which we can cancel 3zx minus 3zx and just leave limit of 9x minus 1 times 3zx plus 1 over 9x minus 1 as x approaches 1 over 9. Okay, again, we can see which we have 9x minus 1 in the numerator and also denominator. So we can cancel 9x x minus 1, 9x minus 1. Then we have limit of 3 zx plus 1 as x approaches 1 over 9. So we know, we just substitute 1 over 9 into zx. Simplify, we get 3 times 1 over 3 plus 1. And finally, the limit value is 2. Example 7. We are given 3 limits, but only 2 limits will be discussed in this video. For example 7c, the full solution has been given in your module. Okay, let's try example 7a. As usual, we try to substitute x equal to 3, and yes, we get 0 over 0. Actually, we do not have to show this method. You just can calculate manually or using calculator. So if we get 0 over 0 and the function or the fraction has set, so we know we need to use multiplication of conjugate methods. Since the denominator has set, so we multiply both the numerator and the denominator by the conjugate of the denominator, that is zx plus z3. For the numerator, okay, we already understand that we no need to expand because it has different types of expression. One has no z and another one has z. So we just expand the denominator. Okay, so from the previous example, we noticed that when we multiply two z expression, which they are conjugate to each other, okay, like this example, okay, zx minus z3 is the conjugate for zx plus z3, and zx plus z3 also is the conjugate for zx minus z3. Okay, they are conjugate to each other. Then the two middle terms, okay, will become 0. So that's why we just expand the first term with the first term. Okay, zx times zx. So we get zx squared. And the last term with the last term, negative z3 times positive z3. So that's why we get negative z3 squared. And we can apply the rule of z in the denominator, and we get like this. Okay, since x squared minus 9 can be factorized, so we factorize it and get x minus 3 times x plus 3. And here we notice that we have x minus 3 on the top and bottom. So we can cancel x minus 3, and just leave limit of x plus 3 times zx plus z3 as x approaches 3. And now we substitute 3 and get 3 plus 3 times z3 plus z3. Simplify, and last, the limit value is 12 z3. Okay, example 7b. We are given limit of 2 minus z6 minus x over 1 minus z3 minus x as x approaches 2. So as usual, you can try to substitute the approach value 2 into the fraction. Yes, we get 0 over 0. So we already know when we get 0 over 0 and the fraction has z, so we need to use multiplication of conjugate methods. Okay, so before we proceed the method, Okay, please refer to this example. Okay, so now we have set expression for both numerator and the denominator. Better we split this limit as like this by using properties of limit. Okay, then next, okay, we can multiply both numerator and the denominator, okay, by their own conjugates. Okay, so we get like this, which is limit of 2 minus 6 minus x times with its conjugate 2 plus 6 minus x over 2 plus 6 minus x as x which is 2, okay, and multiply by limit of 1 over 1 minus 3 minus x times 1 plus 3 minus x over 1 plus 3 minus x, which 1 plus 3 minus x is the conjugate of 1 minus 3 minus x. Okay, since 2 minus 6 minus x and 2 plus 6 minus x is a conjugate to each other, also same with 1 minus 3 minus x and 1 plus 3 minus x, which is they are conjugate to each other. So we just expand first term with the first term and the last term with the last term. Okay, so already same with this denominator. Okay, we just expand the first term with the first term and the last term with the last term and get like this. Okay, so here we apply rule of third. Okay, at the left side we apply the rule of third, and the right side we apply the rule of third at the denominator and get limit of 4 minus 6 plus x over 2 plus 6 minus x as x approaches 2 times limit of 1 plus 3 minus x over 1 minus 3 plus x. Okay. Then we simplify 4 minus 6. Also we simplify 1 minus 3. So we get limit of x minus 2 over 2 plus 6 minus x as x approaches 2 times limit 1 plus 3 minus x over x minus 2 as x approaches 2. Okay. Here we notice that we have x minus 2 on the top and also on the bottom. So we can cancel x minus 2 and x minus 2 and just leave limit of 1 plus 3 minus x over 2 plus 6 minus x as x approaches 2. So now it is in the simplest form. Then we substitute 2 into the fraction, simplify, okay, and get the limit value is 1 over 2.